Hello everyone, today Avinash and I are going to present on urban heat island mapping. Here's the quick overview. First, we will define urban heat island and state our objective. Second, we will discuss previous research and some of their pros and cons. Third, we will offer three solutions to meet the objectives and explain how our solutions address the cons in previous research. Finally, we will examine how our solution contribute to the society's good. The objective of this presentation is to develop a more efficient and accurate way to collect air temperature across a city, in this case, Richmond. So why would we want to collect air temperature? Because air temperature reflects the condition in which people are living in and can affect quality of life. Within the urban area, there are areas concentrated with concrete structures and thus have a higher temperature than outlying areas. These hotspots are called urban heat islands. One of the previous research is done by Dr. Fong and his colleagues. In his research, 20 teams of volunteers rode, bike, and worked across Richmond City to collect the air temperature using handmade sensors. This approach, although cheap, relies heavily on the labor force. Another research is done in Wisconsin. In this Wisconsin research, permanent temperature sensors are used. This approach, although does not rely heavily on labor, is very expensive. As we can see, the cost of 150 sensors is around 40,000. That's not good. We want a solution that can offer both cost efficiency and minimum labor. The first solution our team proposed is to use the microcontroller Arduino, coupled with the software such as Raspberry Pi, MATLAB, and Python to automate the collection of air temperature. As we can see, for 150 sensors, our approach only costs $3,400 as opposed to $37,000 of the Wisconsin research. That's 1/10 of the cost. Plus, our approach only requires labor at the installment stage, hence meeting the requirement of the reduced labor. To further reduce our cost, our team proposed a second solution to minimize the number of sensors needed while maintaining some confidence with the inference of our metrics. We utilize k-mean clustering to find the optimum number of k on a number cluster that can group similar temperature areas within a city. Furthermore, we can use historical events and features to predict hottest, coolest area within a city and mitigate these extremities. Next, Avinash will show you the code that link Arduino and MATLAB. Then he will talk about our third solution to the problem.
Here, the first code records the 10 seconds of temperature data. Second code right here is the most important one because it displays the live data from the sensor that are placed around the city. And the third code right here plots the recorded data into our graph and helps us to measure the lowest and highest possible temperatures throughout the time. Next slide. Our third solution is to use satellite data that collects surface temperature to predict air temperature based on an index known as brightness temperature. Next. We are provided with this data from satellite at little to no cost. This way of estimation of air temperature is biased and may provide less accurate heat models, but this method can be useful from time to time. We can measure and predict our heat analysis for a larger period of time with a given satellite temperature. We can compare this predicted model to our model and we can make our process of heat measurement more efficient. For example, we can take a predicted heat map and use it to lower the number of sensors. This helps us to find the most optimal way of measuring air temperature around the city. So what would be the impacts of our model? The main objective of this assignment is to improve analysis of heat mapping. Immediately with efficiency of heat mapping, we can educate the residents on the risk of heart-related illness. From our approach, we can let the residents know what area they are residing in and how they would be impacted. We can also prepare more emergency services for this area where the heat island would be most impactful. In the long term, we can classify the areas of the city that requires more cooling factors such as vegetation and water ponds. We can also initiate different approaches to cooling by growing vegetative layers on rooftop or using different paving materials other than black asphalt. And
Yeah, this is the end of our presentation. Thank you very much for your attention.
thank you.